Alright, hello everybody. Welcome back, to trigonometry. So, I know, again, I said that I'm not gonna prove any of these identities that I showed. I proved the sum and difference angle identities for, sine, cosine, and tangent. Even though I didn't really include the tangent identity in, thingamajig, the, video of trigonometric identities, because it's not really needed. I keep saying that, but like, I mean, if you can keep it in there, you might as well. So, yeah, but it's more important to know why. Because some of these are actually just really simple, but you just need to know the other ones. Like, for example, when we had to do we just had to do the sine of a plus b, or alpha plus beta. I'm gonna use a plus b and a and b in this video, but we just have to do sine of a plus b, and then when we found that, we can go to sine of a minus b, and we can go to cosine of a minus b, right? Because yeah. Then we can also go to cosine of a plus b, and then we can also go to the tangent of a plus b, tangent of a minus b, stuff like that. So we just needed to prove one thing, and then you can understand the rest. So like, we just needed to know this, and then we know everything else. So yeah. And then also another thing to help kind of like memorize, when like, if you know like an idea but you're like, oh, is it plus or is it minus, then just plug in some simple values. A book said that, like, just plug in 90 and 0 or something like that, or just 0 and 30, something like that, that you definitely know. Okay, so now now we're gonna talk about the double and half angle identities. So double angle identity is gonna be really simple, but the half angle is gonna be a bit harder, but not that hard. So we know that sine of a plus b, just a recap because we're gonna need this again. So now we can use the same thing again to prove another thing, and we're also gonna be needing cosine of a plus b, which you also know. So we're gonna just need that again, but we got cosine of a plus b from cosine of a minus b, which we got from sine of a plus b. So really all we need is the sine of a plus b, and we know the rest of the sum in different angles and the double angles, and from double angles we're gonna get half angles. So yeah, it's kind of a simple thing. And from double angles and half angles, we're gonna get to product to sum and sum to product, which I finally understand more of. Because they were kind of like a weird thing. So yeah, so sine of a plus b. We know that's equal to the sine of a times the cosine of b plus the sine of b times the cosine of a. This cosine of a plus b is equal to the cosine of a times the cosine of b minus the sine of a times the sine of b. Yeah, you can see the symmetry and differences and stuff like that between them. So now if we set b is equal to a, what we're gonna get is let's say b equals a, then we're gonna get the sine of a plus a, which is the sine of 2a, which is what we want, and then the cosine of 2a. It's equal to the sine of a times the cosine of a plus the sine of a times the cosine of a. Right? That's kind of cool. Now we notice they're the same thing, so we just get 2 times the sine of a cosine a. Right? That's pretty simple, I think. Now cosine of 2a, we have cosine of a times the cosine of a plus sine of a, or minus sine of a sine of a. That's equal to cosine squared of a, or cosine of a squared. We just don't write cosine of a squared like this because we can confuse them with the parentheses. So yeah, we just write it like this, minus sine squared of a. Notice that we see the squares of cosine and cosine. So we see the relation with the Pythagorean, the trigonometric Pythagorean identity thingamajig, which is cosine squared of a plus sine squared of a equals 1, no matter whatever angle a is. So now we can use that here, and if we say, so that means from that sine squared of a is equal to 1 minus cosine squared of a, and cosine squared of a is equal to 1 minus sine squared of a. So what we can do is we can say that's equal to 2 cosine squared of a minus 1, because sine squared of a is 1 minus cosine squared of a, so that's going to be cosine squared of a minus 1 plus cosine squared of a, and this is what we get. If you plug in cosine squared of a equals 1 minus sine squared of a, we're going to get 1 minus sine squared of a minus sine squared of a, yeah, and that's going to be 1 minus 2 sine squared of a. Again, we see the relation between all of these. There's one of each in the first one, then there's 2 of cosine and cosine squared in the second one, and there's 2 of sine squared in the third one. And then we see the relations that the minus is keeping its maintenance with the sines on the right and the cosines on the left. So we also have this, and we also have this. Nice. So now we have those. So now you might be wondering, how are we gonna find the sine? Yeah, how are we gonna find the sine of say a over 2? That's a bit harder. So what we're gonna do is we're gonna we're gonna set a equal. So yeah, actually what we're gonna do is we're gonna make a substitution for an angle. We're gonna say theta. So we're gonna say that, and we're gonna use wait, let me write this one too. Something over 2. We're gonna use a basically, but yeah. So what we're gonna do is we're gonna make a substitution. We're gonna say that theta equals a over 2. So this is just theta, I guess, but what we're gonna get is oops. Wait, yeah. So now we can rewrite the double angles, right? We have 2a, If we say theta is equal to a over 2, wait, theta is equal to a. No, sorry, a is equal to theta over 2. Sorry about that. Yeah, if a is equal to theta over 2, then we're gonna get this is equal to the sine of theta over 2 times the cosine of theta over 2. Oh wait, no, sorry, we can use the double angles, right? Sorry about that. I was looking at this. Yeah, sorry. So now what we can do is we can say that's equal to 2 times the sine of theta over 2, right? Times the cosine of theta over 2. This doesn't really get us anywhere. So we can't really use this. What we can do is we can put that into this. Maybe we'll get somewhere with this. So we do cosine squared of theta over 2 minus sine squared of theta over 2. If we're looking for one of them, we're not going to get anywhere, because there's going to be the other one just hanging around. So how can we get rid of the sines, or how can we get rid of the cosines? Well, we can use one of these two, right? So what we do is we say that if we plug in into the first one, 2 is cosine squared of a minus 1, we're going to get 2 cosine squared of theta over 2. Oh, by the way, because theta a is equal to theta over 2, 2a is actually just equal to theta. Same thing, but yeah. So now cosine of theta is equal to 2 cosine squared of theta over 2. Because of an alternate form of sine of theta that gets rid of one of the sines or cosines, we're going to use cosine, meaning, sadly, that our half angles are both gonna be in the form of cosine, which is gonna be kind of weird for sine. So yeah, we're gonna have 2 cosine squared of theta over 2 minus 1, and then we're also gonna have the cosine of theta is also equal to the 1 minus 2 sine squared of theta over 2. Right, so now we're looking for theta over 2. So what we can do is we can add 1, divide by 2, and square root. So what we're going to do is we're going to get the cosine of theta over 2 is equal to the square root of cosine of theta plus 1, or actually I'm going to write it like, hold on, just for the symmetry with the other result. Oh, oops. With the other result, I'm going to write it like this. Yeah. Square root of 1 plus cosine of theta over 2. So now, that's nice, but when we square, but we had something squared, and then we square rooted it. So you might notice we need a plus minus there. That doesn't mean that there's two solutions. I'm going to discuss that in a bit, but yeah. And then here we're going to have the sign. We can do the same thing. Except this time we subtract 1, divide by -2, and then square root. So what we're going to get is sine of theta over 2 is equal to positive or negative square root of 1 minus cosine of theta over 2. These are the simple derivations of the double angle, which is a derivation of the sum and difference angles. So these proofs are really just connected to one another, and there's nothing really new. We just know the basics, and then we expand and expand and expand. So yeah, now I'm going to discuss the plus or minus signs. So when we have a coordinate grid, here are the quadrants, right? Wait, no, sorry, no. What am I doing? Yeah, so these are quadrants. Now, so notice that when hopefully we have some idea that about the unit circle, right? The coordinates are cosine comma sine of the theta, where the theta is the angle it makes with the positive x-axis. So what this means is that in the first and second quadrant, the y value, which is sine, is positive, and the third and fourth is negative. And then for cosine, it's positive in the first and cosine is positive in the first and fourth quadrant, while negative in the second and third. So yeah, hopefully we have some idea. If not, if you're doing in the test and we have 2 minutes left and just one question, we can just draw this, and then we can say, okay, why? Yeah, we can have an idea. So now, based on that, we can, yeah. So to know whether to use plus or minus, we just use whatever sign not sign, but whatever symbol, like the plus or minus, based on theta over 2. So if theta over 2 is positive, we're going to use a positive one. If theta over 2 is negative, we're going to use a negative one. So yeah, that's basically just how you determine. So yeah, that's basically it. Thanks for watching. Oh, let me square these, or rectangle these. Okay, thanks for watching. I'll see you guys next time. Goodbye. Oh yeah, I think I'm gonna talk about sum to product and product to sum next time. So yeah, goodbye.